In this video, we'll be going over how to calculate the oxidation number when you're given a Lewis structure. Let's start by calculating the oxidation number of fluorine. The most important concept is to remember that the more electronegative element owns the electrons in the bond. So let's just first determine which electrons the fluorine owns. Well, we should look at this bond between the fluorine and the carbon and see which element's more electronegative. Here I have an electronegativity table showing the values, and you can see that fluorine is more electronegative than carbon. It has a higher value. If you're not given one of these tables, you can just use the periodic trend that the electronegativity increases as you go up and increases as you go right, with fluorine being the most electronegative. So since fluorine is more electronegative than carbon, that means that fluorine is going to own both of the electrons in this bond. And fluorine also has 3 lone pairs on it that's not sharing with any other element. So it also owns those electrons as well. Once you determine which elements or which electron the element owns, then you can just use this equation. The oxidation number is going to equal the number of valence electron minus the number of electrons owned. So for fluorine, fluorine has 7 valence electron, and we know that because it's in the 7th column. 1, 2, 3, 4, 5, 6, 7. So it has 7 valence electrons. Then we're going to minus the number of electrons owned 1, 2, 3, 4, 5, 6, 7, 8. And so its oxidation number would be -1. Each bond counts as 2 electrons, so that's how we got a total of 8 electrons that the fluorine owns. Okay, now let's take a look at the next example, which is, why don't we look at oxygen? So oxygen doesn't have any lone electrons around it. It does have this bond, so we're going to see whether oxygen is more. Sorry, I meant to say hydrogen. I don't know why I'm saying oxygen. Let's calculate the oxidation number of hydrogen. Hydrogen has no electrons around it, and it has to share this one bond with oxygen. Hydrogen is less electronegative than oxygen. That means hydrogen doesn't own any of the electrons in the bond. So hydrogen doesn't own any electrons. Then its oxidation number will be 1. The valence electron for hydrogen is 1, minus no electrons because it's not owning anything. So its oxidation number will just be +1. Next one, let's take a look at oxygen. Oxygen is more electronegative than hydrogen, so oxygen is going to own both of these electrons in the bond. Oxygen is also more electronegative than carbon. You can see oxygen has a higher electronegativity value than carbon, so it's also going to own both of the electrons in this bond, and it's also going to own the lone pairs because the lone pairs are not shared with any other element. Then the oxidation number of the oxygen will be the number of valence electrons, 6, minus the number of electrons that it owns, 2, 4, 6, 8. So the oxidation number of oxygen will be -2. Okay, how about this? Let's take a look at this carbon now. So that carbon's less electronegative than fluorine and oxygen, meaning it's not going to have own any of those electrons. It is more electronegative than hydrogen though, 2.5 versus 2.1, so it's going to own both of these electrons. And then here we have 2 carbons, and since they have the same electronegativity, they're going to share their electrons and split it. So that means this carbon's only going to own half of the bond, or just one of the electrons in the bond. Then this oxidation number will be 4. The valence electron for carbon is 4, minus 1, 2 in this bond, and then 3 in this bond, since we're only getting half the bond. So it'll be 4 minus 3, so the oxidation number will be +1. Okay, next one. How about let's go with this double bonded carbon. Well, this carbon and that carbon has the same electronegativity, so it's going to get half. Carbon we said was more electronegative than hydrogen, so it's going to own both of those electrons. And then we again have a carbon-carbon situation, so they're going to just split. So they're going to get 1 electron from each bond. So the oxidation number of this carbon will be 4 minus 1, 2, 3, 4, 5. So 4 minus 5 is -1. We're getting the 2 from the bond here, and we're getting 1 from each of these bonds since they're all split. And then let's go over just 2 more example. Next one, we're gonna have to repeat color because I'm running out of colors. Carbon. Take a look at this carbon that's triple bonded. Well, carbon and carbon, so they're gonna split. Carbon and nitrogen. Nitrogen is more electronegative than carbon, so it's not going to own any of the electrons on that side. So then it's oxidation number 4 minus just 1 because it's only getting 1 electron on the left. So its oxidation number will be +3. And then lastly, let's take a look at nitrogen. Nitrogen we know is more electronegative than carbon, so it's going to own all the electrons in the nitrogen-carbon bond, and it's also going to own the electrons in the lone pair. Then its oxidation number will be 5 since its valence electron is 5, minus 2, 4, 6, 8, minus 8. So its oxidation number will be -3. And that's how you can calculate oxidation number when you're given a Lewis structure. Just start by circling the electrons that the element own, and then using the equation, oxidation number is equal to number of valence electrons minus the electrons owned.
If you want to learn how to ace chemistry, if you want to learn what's the best way to study for this class, if you want to learn some neat tricks and tips to take into your exam and do better in them, then you should head over to my website and get this free guide, 12 Secrets to Acing Chemistry. You can head over to www.conquerchemistry.com/chemsecrets. I'm going to include a link in the description below. Check it out. I think it's really going to help you, and you're gonna like it. Until next time, keep working hard and continue the good work.